Hi, everyone, and thank you for joining our call today. As far as after looking at the calendar, I understand that this is probably the last developer call that we would have in 2021. So, for those who have been with us over the past year or years, thank you very much for being with us. For those who are joining us for the first time, I also can say thank you. And over the following year, we will also have regular dev calls. So just sign up to our YouTube channels, join our Telegram chats on Reddit, on Twitter, join whatever you can or want to, and stay tuned because in the first half of 2022, we'll have a lot of huge updates on everything that we're doing. Um, yeah, so following the links would be very, very much helpful to you. If you have any questions, either now, like if you have any questions now, you can either speak up or you can drop them in the chat of the call. I'll then read them out loud and ask the questions to Maxim or answer them myself if I know the answer. Afterwards, all the recordings, they are being uploaded to the GitHub repository, to our YouTube channel. And we have two resources that are being updated. One is the wiki page on one of the repositories. It's the devcall repository under the LNPBP Standards Association GitHub organization. And it's the community section under the RGB FAQ website. There you can go there, like rgbfaq.com. You can see the developers, the community section, developers call, and you can see the agendas of the call. You can see all the links, briefly mentioned questions that we covered, and that would help you a lot to navigate. We're also planning to update all the documentation that we have, including the RGB FAQ website, actually, over the following weeks. So it's going to be also very, very fun and like present for the New Year's for us and for the community too. Yes, and the topic of our call today is going to be the LNP node. Probably I can try to introduce the concept of the LNP node for now. It was born actually during the first Lightning hackathon, which was organized by Furmo and Rudzol, which are guys from Raspberry Blitz. Probably everyone knows them. And right now it has become this huge, fully fledged node, which supports, which follows a lot of standards of Lightning, a lot of bolts, which also supports the Bifrost, which is the generalized Lightning Network protocol that we have created. And basically, if you look at the LNP node, it's just another Lightning Network node. It can or cannot, I mean, you can use it with RGB or without RGB, as long as you like, however you like it to work. It's very modular, and probably we already had a couple of calls and 2 demonstration calls about, actually, I think 4 demonstration calls about the work of it. So feel free to go to the YouTube channels, to the RGB FAQ website, and check the recordings out. And right now we're moving towards making channels, right, Maxim?
Yes, correct. So I can probably start from here.
Yeah, so now you can take over. Mm-hmm.
Yeah, the call of today will be the third part of the demonstration of the LNP node functionality. It wouldn't be the last one because still we have a lot of work ahead to do and to showcase after. And on the last time, it was quite technical, and I will deliberately did a technical call such that future developers may watch it and know how to join the actual code writing for LNP node. This call will be less technical, a bit less technical, still quite technical, but not to that level. And if last time, the previous week, we had covered the LNP node architecture, we had a demo how to set up the actual node and how to control the node from the command line. Also, we covered this LNPBP 64 proposal for hierarchical deterministic key derivation for Lightning, which we will be also discussing today once again in more details. And at the very end, we had a demo of channel initialization, which actually we didn't have the time to fully complete. So today, we will do that, and we will start with a description of how actually channels are in Lightning are created, and how this creation, because it's quite a complex process, is built into LNP Node. After that, we will have a full demo until the channel active state of the opening channel between LNP node and remote C Lightning instance. And that is important that we are using two different nodes to demonstrate full interoperability with the modern Lightning network. Then we will also show how the channels are actually persistent on disks and can be restored after the node termination. So for instance, I will kill the node and show that after that it can boot up and get in contact with the remote C Lightning and get channel operational once again. So that's important part of the security of the node. Then we will talk a bit about the roadmap and action points for further development. We will need your help as well. So I will be specifically pointing out parts where you may be helpful. And at the very end, if we will have a time, there is several slides where I would like to discuss how the LNP stack of protocols can be layerized, how this vision can be put on the existing Lightning network architecture and compared to other architectural descriptions of it, for instance, from the Mastering Lightning Network book, and how it fits with the future developments, but the developments we are doing with LNP Node currently, and the developments we are planning to do next year. So I will start with the workflows, but before doing that, just give me 1 second. I will pour some water for myself because it will be quite hard to talk through the whole call without drinking.
Sure.
So I had time to do that before the call.
I think you can also pour yourself some coffee and prosecco if you like.
No, just water today. Just too tired even to drink. The workflows. As you probably know, in Lightning Network, there is a process of channel establishment or channel creation. And this process is initiated by a user on one side of the future channel. It gives a comment to the local node. And then node contacts the remote node and asks for accepting the channel from that node. And there is certain process happens, which ends up with an actual functioning channel. I have to say that this is a much more complex process. It's well described in bold standards. Well, described in all details. I wouldn't say that it is well described, but at least they have most of the information that is needed for doing the implementation of Lightning Node, because basically the LNP Node is an experiment where we try to write a Lightning Node from scratch based just on the standard text. So we haven't used any part of any existing node, any existing libraries other than Rust Bitcoin, which is not Lightning specifically. And with this experiment, we found out that actually it is possible to create a new Lightning Node implementation just basing on the standards. And we found that probably one of the most complex parts of the implementation is the channel establishment. Why? Because it involves a multi-staged workflow. Basically, you have to exchange about 6 messages with the remote node. in different order. They may arrive in different order, and you have to maintain different situations depending on the response of the remote node. So in fact, you have to deal with a state machine that switches the state during the channel establishment from one phase to another. And that's why our decision for implementing the channel operations and any actually workflows which come from the Lightning channels, like channel creation, payments, routing, and so on, as a proper state machine. So if you will give me one moment, I will show you the actual code. It's on the other screen. So here is LNP Node repository. And if you will see the source code, there is a daemon. The organization of the source code is, I will collapse this, is made of daemons mostly. And these daemons are talking to each other. We were covering the architecture of these daemons and how they interact on the last call. So I will ask to look at that video for those who are interested. But basically, we have a channel daemon. We run as dedicated channel daemon instance per each channel. We have LNP daemon, which is a managing daemon, managing all the rest of the daemons. We have a peer daemon, a daemon that talks to the remote peer. And we run a separate instance of peer daemon per each remote node. And this separation of the channel daemon and peer daemon is quite unusual. If from what I know, other nodes do not separate them. And for instance, C Lightning, it allows only a single channel per peer. With our architecture, we can't have that because we would like to support in the future multi-peer channels. And that will imply that with some peer, you will have several channels with the different setups and with the different other participants. So that's why we did this separation. And also routing daemon doing the signatures and keeping the private keys and secrets, and watch daemon that actually does on-chain tracking of the transaction mining. So these are the daemons that make LNP Node. But what I was going to say that basically in some of these daemons, like the most complex one in peer daemon, in channel daemon and LNP daemon, you will have this directory automata. These are state machines, specific dedicated for certain workflows. For instance, if we are talking about channel creation, we will see that there is a channel propose workflow consisting of clear stages. And while we are going through the stages, we pass each message that comes from the remote peer to the state machine. And the state machine accomplish switching from one stage to another, depending on the message. So we have quite a deterministic order of the reactions, how our node reacts on even unpredictable sequences of events. If the sequences of events are not matching the specification, we of course fail the channel creation as said by the specification. But additionally to that, the problem is, while we're having this multi-daemon architecture that allows us a lot of flexibility, I was saying that it allows us to spread the node across multiple servers and or embed that into a mobile device or divide some parts of the node between mobile and the server side. The drawback that we had is the fact that it's not just our program and the remote peer who talks to each other with a certain workflow. It is a multitude of our own daemons that need to talk to each other within that workflow scope. So what we did is we created a workflow chats, which are kind of a part of the LNP Node documentation, which specify how exactly LNP Node behaves during these complex workflows. You will be able to find them in the doc directory here, workflow subdirectory. We have a rendered PNG version and also textual representation in mermaid format, from which we actually generate the image. And you see here that the main participants are the client. I will go briefly through the workflow because basically when I will be showing it from the command line, you have to understand what happens and how this thing, channel creation, is processed. So the command line client initializes the create channel with an open command in the console. we will start with that. And this command goes to the main managing daemon, which does the launch of the channel daemon. So it basically creates a new channel daemon for that specific daemon, for that specific channel. And at the same time, it asks a signature daemon to derive a key set that channel daemon will operate. And this key set derivation, how it is done, we will be discussing after the demo. It's basically the proposal that we did, because like in both proposals, they don't specify how exactly you derive these multiple keys used in the channel. But having them derived deterministically is quite important in terms of channel recovery if you lose the channel information. So we will discuss how it can be done in the best way. And they do that. The channel daemon bootstraps and the signature daemon produce a new, it derives a key set in asynchronous mode. And at the end of the day, LNP daemon collects both results and then it forwards these results to the channel daemon, informing the channel daemon that there is a remote peer. The remote peer, please send the open channel request to the remote peer and use this key set, which actually channel daemon does. And it waits for the acceptance of the channel from the remote peer. So here is the remote peer we are talking to. And when the channel is accepted, the channel daemon needs to fund the channel, and for that it asks the LNP daemon, which holds the funding wallet. The funding wallet is a cold wallet, doesn't having any private keys in it, and this funding wallet creates a PSBT that will fund the channel. The most important, this PSBT is not yet signed, and this PSBT is needed to generate the first commitment transaction. This transaction is generated by channel daemon, and then it uses a sign daemon to sign this commitment, not funding, but we first sign commitment transaction, such that if the remote peer is cheating, he will not be able to put all our funds onto multi-signature such that we wouldn't be able to spend without him. So we start with assigning the first commitment transaction, which is also called refunding transaction. And we generate the refunding transaction using the key set that signature daemon created. And we ask, actually, because we don't have any private keys, nobody has the private keys in this setup other than signature daemon, which may be remote or maybe a hardware device plugged into the server. So we ask the signature daemon to create the signature for the refund transaction. We send the signature to the remote peer, waiting for the signature from his side. And after that, we are asking LNP daemon to publish that PSBT, the funding PSBT it created. But because of LNP daemon, managing daemon, doesn't have private keys either, it asks a signature daemon to do the signatures. And only after the signatures are done, the transaction is published, and then we are tracking it with our own chain. Actually, it is renamed into watch daemon. And when the transaction is mined, we got the locked and active phases. And finally, the channel is established. So you see how many stages are there for channel creation. It's probably the most complex workflow in the Lightning Network specification. The payments, HTLC routing are much simple. And I'm quite happy that we actually completed the implementation of this workflow on 100%. There is the other side of the workflow, which is channel acceptance workflow. It is much simpler, more linear, and that's why we will be demonstrating the LNP node doing this more complex workflow. So let's jump into the demo. And for that, we will need a command line. We will have two command lines here in the left part. I will be running the daemon itself, LNP daemon, LNP node. Here I will be typing in the command line commands to operate it. And on the next screen, I have our server, the C-Lightning server. You see that's a different server. And I'm connecting to it via SSH terminal. You will see that here we have a lot of processors and Bitcoin node and other nodes and Electrum server on that remote machine. Here we just have my notebook, local notebook. And they will be talking to each other. And we will be tracking the status of the Lightning daemon over the mainnet using the logs reporting, because Lightning daemon runs in the Docker instance. So we already have a node set up, and it is set up from the previous call. So we will just run the node with this command, LNP daemon, on Bitcoin mainnet in debug mode. 3V means debug, 1V is error, 2V is informational level of reporting, 3V is debug, and 4Vs, the most of that is just tracing information, where you will get a lot of details on the structures which are actually produced, printed on screen. And the threaded daemon means that all of the instances of these daemons will run within a single process. So I will use that command. And our node has started. We have a node ID here. We opened a funding wallet, which we created last time. I have to say that actually there was a problem with the creation of funding wallet in the previous version. It is fixed in this version, but there was duplication of a single step of the derivation, which caused me to lose one day on debugging why I can't sign the funding transaction. So I had to manually fix this derivation part here. It wouldn't happen if you will clone the LNP node, because the problem is fixed, and when you will use LNPD init command, it will create a proper funding wallet without this duplication. But let's hope that the signature will work with that correction. It works on the testnet. I haven't tried it on the mainnet yet, and let's hope that, yes, I did a proper feature of the derivation. If not, we will fail back to the testnet, which certainly works. Or we'll regenerate the wallet and fund it once again. Okay, so we are operational, not connected to anybody. Let's check that with the console on the other side. We have a lightning click command. We can get info. We see the private key here. It ends up with a 5B73. We don't have any peers. We don't have any channels. Yeah, we are pure and native. So having login here and doing the connection. We do connection with the connect command. Actually, we can first of all check for the funds. Yes, we have some funds on the address. We have 100,000 satoshis. We can get the overall info of the node, node ID, and uptime, and channels, peers connected, none of them are connected. And now we will do this connect command. I need to make sure, yes, 5B73, that I connecting the proper node. And here we are, the peer connected. We have a success status. And here we see in blocks that green part. And if we will go to the C Lightning, we will see that it received and sent the initialization command. So if we will interrupt the login and we will list peers, we will see that we've got this new peer with our node connected to the C Lightning. The same on our end. If we will check the info, we will see that we have a peer connected, which is the remote Lightning node. We can actually get more info about that specific remote peer by issuing info command, providing it with the node address. Let's just copy it from here with the peer address, remote peer address. Yes, we see that it is being connected, uptime, messages exchanged to each party, and no channels yet. So let's create a channel. You see that the daemons are exchanging ping pong messages with each other, so they feel nice. And we open channel with the open command. Yeah, I have here it in the history, and the open command is
Maxim, ping. We cannot hear you.
Hello, do you hear me?
Now, yes, but you were muted for over the past 40 seconds or something.
Well, on which part have I stopped?
When you switch to the left screen.
Did you heard the creation of the channel?
Nope.
That's very bad because actually that's what I did, and I can't create another channel with the remote Lightning instance. But you see from the screen that basically I issued the open command
Yes.
with the amount of satoshis I'd like to to put into the channel. I provided the remote peer address, and we got through this process, which actually involved launching the new instance of channel D, derivation of the keys I was talking about, channel daemon connecting the remote peer, proposing a channel to the remote peer with a temporary ID, constructing funding transaction with the out point that we had on the funding wallet. Here, if you will check that with these funds, and switching into the permanent channel ID. The remote peer accepted our channel, and it provided us with a signature. Actually, no, we signed it locally first, and then we sent the signature to the remote peer that we got the signature from it. We signed the funding transaction. This is the address of the funding transaction, and we published this funding transaction for the channel. So it says the channel is created and active. You see also here a lot of operations happening, publishing transaction and producing it. And let's check that. We actually had something. So we see that Lightning. Do you hear me?
Yes, now everything is good.
That Lightning got the open channel, responded with accept channel, funding created, and signed funding transaction. And now it waits for the transaction to be mined. So if we will check the funding transaction in their block explorer, we will see that there is a funding transaction which actually puts 75,000 satoshis to the from the funding wallet. The change is allocated back to the multi-sig 2 of 2. I will increase this 2 of 2 multi-sig of our channel. And we will need to get the transaction mined such that Lightning will be happy with the channel. If we will check Lightning daemon with peers, we will see that the peer is connected and there is a channel awaiting the transaction to be mined. On testnet, it happens instantly, of course, or nearly instantly. On mainnet, we will have to wait for about 10 minutes. We have this channel ID produced, and basically, let's spend some time. 75,000 satoshis allocated, the amount that we actually paid for, and we need to wait some time for the transaction to be confirmed. On the Lightning node side, if we will check the info of the node, we will see that there is a channel also being in the process of establishment, and we can get the info about that channel, and we will see a lot of details. So we have quite detailed information on reporting. So this is the info on the channel. And we got a funding PSBD with all details if you need to debug and derivation path for each of the keys. These derivation paths are actually ones which we will be discussing later. The outputs, where the first output is the witness script for the 2 of 2 multi-sig for the channel funding. We have a stage funded, not active because it's not mined yet. So the channel is funded, but not operational still. We're waiting for mining. On the Bitcoin mainnet, this is Genesis of Bitcoin mainnet. We have a channel ID, permanent channel ID, and we have the same amount of millisatoshis allocated to it. And also we have details of the channel like policies we created. These policies can be edited via configuration of LNP Node. For instance, they set up the ranges, how many funds we would like to allow in the each TLC, not to expose a lot of vulnerability the HTLCs got stacked, or how many channel reserve we are able to accept, and so on and so forth. So there is quite a lot of details, how long we should wait for the transaction, at which depth the transaction should be mined for the channel confirmation. These are policies, it's not the channel setup. So these policies are actually limits which we apply during the negotiations with the remote peer. So for instance, the remote peer, if it proposes us a depth of the funding transaction, it should be within this range from 3 to 6. So it shouldn't be less than 3, but shouldn't be more than 6. And C-Lightning actually fits into that limit. That's why we were able to create the channel. If the remote node will propose one of the values for the channel, which will be outside of these boundaries, outside of the policy, the channel wouldn't be created, and the command line will report that situation that actually it is impossible to create the channel. I will show that later on the testnet. There are channel parameters which are for the both parties of the channel and specific to the local node and to the remote node. For instance, we have a different HTLC max value in flight set up by the C-Lightning and our node. Here it's much less. And the reserve for the channel in Satoshis is set differently, and so on and so forth. Finally, we have a set of the keys used by the local node. And in here we have not just the keys, not just a base point from which we derive keys for each of the transactions, but also information about their derivation paths. Again, the topic we will be discussing later, you will see that they use a channel-specific part of the derivation path, which actually takes some bits of the channel ID. And the remote set of remote public keys. Here we don't know how they are derived. The Lightning protocol doesn't require the remote node to report the derivation path for them, so just the keys. And the number of HTLCs which are none. And that's all. And the remote peer we have in channel with. And this is the printout information, info information from LNP client is always in YAML format, such that you can simply parse it if you would need to parse it from any other tool, or you can read it, because if we will stick to JSON format, it will be really hard to read from the human eye perspective. The YAML format, it can be both parsed by computer and by human eye. So that's why we selected the YAML format, which is easy to read. So let's see what happens to our transaction. It is still unconfirmed, unfortunately. We are doing on the mainnet, so it takes time. And while we are waiting for the confirmation, I will probably switch to, I will continue the demo, not on the part of the node, but on the other part of the story. Well, I actually can show you how you can fail the creation of the channel with the testnet. So I will switch to the different command line and we'll run an instance over the testnet. Let me do that. I will increase the size of the font. No, I can't do that easily, but anyway. So LNP daemon. LNP daemon run on the testnet in verbose mode, just like that. Oh yeah, and we need to use a different address because we are already using the that address with the mainnet for the RPC service. So we will use the port. We will use different port P. No, not this one. Yeah, we provide this together. So we will use RPC address. One, let's say 63.962. Yeah, here we are. We will use this flag in the command line tool as well, such that the command line tool connects to the proper instance, which is testnet, not mainnet. And let me try LNP clear with this address and check the info that we are connected to the proper node. Yeah, I can't change the address it connects here, probably. Okay, I will be able to do that after I will stop the main daemon. That's why it's much easier if you run them in the containers. But because I'm doing that on the local machine, I didn't have time to set that up before this demo. So let's switch to a different task while we are waiting for the transaction to be mined. Oh, here it's C flag, not R, C flag. Yeah, so finally we have connected to the testnet instance. We are checking that it is indeed that it was we who sent the get info. So we're not on the mainnet, and now we can do issue comments to the testnet instance. So what we are going to do is we are going to connect to the other C Lightning over the testnet, and this other C Lightning runs in a different directory, testnet, which has a dedicated Docker container. If I will run the testnet here, I will see its log. Yeah, and I have specific light test CLI command to send the comments to the testnet C Lightning. And here I will get info such that I have a public key. I have the public key of the node, and I need to connect to that node with IP address, which I will take from the from here. And also, I will have to use a custom port since the testnet runs on the custom port. On the default Lightning port, we have a mainnet instance. I will look into the history. I have that port somewhere. Yeah, this is it. This is it. So we will connect to that instance. We got this connection, and let's check that we have it has seen it. Yes, we've got to the testnet. We connected. Now we have two LNP nodes running on the local machine, one in multi-threaded mode, one in multi-process mode, one over testnet and one over mainnet, connecting to the remote C Lightning, two different remote C Lightning instances. And if I will check here, for instance, for a peer daemon, I will see that this peer daemon runs on the testnet, but I don't have a peer daemon running the mainnet because I'm using the multi-threaded version of LNP Node in that case for the mainnet. So basically it all works as expected. And now I will try to create a channel with a very few Satoshis, which will fail because of that fact. So I will open a channel for, let's say, 5,000 Satoshis, and let's see what happens. We will see that in the logs here, and we will see in the response from the server. So here, oh, it gets connected to the wrong, multiple channels unsupported. So it talks to the mainnet daemon. I don't know why. Oh, no, because I have set up the channel with the testnet daemon. So it talks to correct daemon, but I already have a channel there. So basically that's why it doesn't allow me to create a new one. It's the limitation of C-Lightning. I can undo that by hacking into the database of C-Lightning and cleaning that channel. Anyway, we are waiting for the transaction to be mined, so there is nothing more we can do than to play with these different instances. And I have this, oh, it's a mainnet. No, it's bad. I need to do the testnet hacking, not mainnet. I will wipe everything from the C-Lightning memory with this simple command. Testnet, yes. And I will restart the Docker instance for the testnet. And it will behave like nothing happened between us before. And from now on, I will be able to run again the daemon and connect to it, to the remote testnet node, and propose a channel with a very few satoshis. Yeah, and we got error. You gave bad parameters to. So basically, we are unable to fund that channel with that amount because we actually asked a reserve, which is larger than the amount of satoshis we are funding to the channel. So you see that we actually can also handle the situation when the channel can't be funded. Okay, so what's up with our transaction? Still unconfirmed. Bitcoin mainnet is really, really slow. And the fee unknown. Yeah, we're still far from the top. 1 Satoshi per virtual byte is the amount we agreed with the remote node. Probably I need to increase the recommendations by the remote node for the fees. But it's actually the fees which are proposed by the C-Lightning. Anyway, while we're waiting for the mining, we will probably process to other parts of the presentation. And with this coverage, I would probably go into this LNP-BP 46 Lightning key derivation. The idea is that within the Lightning node, you have a set of keys which are used by the node to sign different transactions. If you will look into our output, you will see that these keys, here we have these local keys, basically you have at least 1, 2, 3, 4, 5, 6 keys used by the channel. Plus you have a key for the Lightning node itself, the key that is used to encrypt the traffic between the nodes. And that key we get when we are getting info about the node. And we use that key. This is the key, the node key, which we are using to connect into the remote node, for instance. So that's a 7 key. And also we have a funding wallet, which we use to fund the channel. So 8 keys. We have 8 different keys. And 6 of these keys should be channel specific, so they have to be derived and generated for each newly created channel. And today there are no recommendations how to do that in standard manner, such that if you will lose the data of your Lightning node, you will have quite a hard time recovering those keys. And the idea of my proposal is that we define, if you remember, there is a BIP43 standard, and it says that when we use hierarchical deterministic wallets, we use the first index for the derivation as a purpose. And the purpose index defines the specific application of the keys that will be derived under this wallet. BIP43 says that the purpose should follow the number of bit proposal that defines that purpose. But because we are not applying the bit proposal for the Lightning Network, maybe it wouldn't work. I don't know, can we do a BIP for Lightning specific applications? I decided to propose use of the Lightning port, which is 9635, and this is also the Unicode number for the Lightning character, as the purpose for all the keys that we will be deriving for all the Lightning nodes. And the name for this key will be the Lightning master key. Basically, when you have your seed, you will create the extended private and public keys with this derivation, and you will use this private key for all of your Lightning nodes to derive the instances of all your Lightning nodes. This will allow to put all your Lightning funds into the single wallet if needed. And this simplifies the management of multiple Lightning nodes and Lightning channels, no matter how complex infrastructure you will have. So this is the Lightning master key. It is important that the nodes itself, they will not operate this extended private key. And even they will not need to access extended public key. So this key will be derived from the seed phrase, and it will be used for the derivation of specific node instance setup, but you don't need to keep it. You can basically delete it and rederive it from the seed phrase when needed. So each of the nodes will be, and each of the channels will be isolated from each other by the using derivation path from below indexes. After the purpose field, all the keys that will be derived will have the second index specifying blockchain, which we will be applying these keys to. No matter are we talking about the node or the channel specific keys or funding wallets, they will all follow and commit to the actual blockchain they're used on. And this is a common practice for other hierarchical wallet derivations. And these values, like 0 for mainnet and 1 for testnet, they are used by other wallets for other purposes as well. So this is quite nothing new here. Next, we will have 3 types of the public keys, extended keys used by the Lightning node and channels and funding wallet. So the keys for the Lightning node, the keys for the funding node, and the keys for the channel construction. The node key, the specific type of the key we derive, is specified at the 3rd index. So we will have 0 for the node key, we will have 2 somebody mutes me. That's very interesting.
Why do
check once somebody has the muting rights.
Why do you think that somebody mutes you?
Because I'm getting the message that Offlow Show is muting me.
What's the name of the account again?
Offlow Show.
Okay.
I kicked him out. So that's how I got muted to the previous time.
Maybe.
Well, okay, continuing. And for the node key, it will be a quite simple setup. So we have this node signifying flag, which is the 3rd component of the derivation path. And we will use the 4th component of the derivation path to specify a node identity. It basically will be an integer, increasing integer, 1 per node. So the first node, it will have 0. The second node, we will assign 1. The third node, we will assign 2, and so on and so forth. No matter how many Lightning nodes you have, you can always order them in by their time of creation. And you will use a hardened index for that. And that will be the actual node key, which will be used for connecting node and publishing node information. The second key, the second type, is the actual derivation for the funding wallet used by Lightning node. And here we will use the 4th component of the derivation path to specify the case. And it is pretty similar to the normal wallets, where you use 0 for normal addresses and one for change addresses. But additionally to that, we propose index 2 for deriving shutdown keys. And the shutdown keys are basically addresses you are putting your funds from the Lightning channel when you close the channel. So that's how you can get your funds back to the funding wallet. That's why this keys, that shutdown key is not derived from the same set as the channel keys, and how you can make the funding wallet controlling all the change funds and funds coming back from the channel closing. Then we have an RGB20 in the future when we will be using RGB20 assets with the LNP node. The basically how, well, we can always put the RGB assets on the same addresses as Bitcoins, but probably that wouldn't be efficient. And this wouldn't be efficient since you may lose your assets if you will reuse the same keys on a different node, not non-RGB aware node. So for instance, let's say you lost your node and then you set up a different node like LND or C Lightning, and you restored your keys using this hierarchical derivation. And you will basically lose your RGB assets because the node will be unaware that these addresses contain RGB assets. So for that reason, the proposal is to use different index here for each cases where you have RGB assets assigned. And in our earlier proposals of using RGB assets, we had an idea that we should use one single index for all RGB contracts. But now I think that it will be desirable to dedicate a special index per each RGB schema. So if you will have a fungible assets, it will be 20, or starting with 20. If it will be NFT assets or RGB21, it will start with 21. So basically the name of the scheme, RGB schema standard, will be used for creating the index for this derivation path component. And again, we will have 3 indexes per each schema for the actual assets, for the change, and for the shutdown script. So that's the idea. And the last derivation path component will be, as normally used by wallets, used for creating addresses like first address, second, third, and so on and so forth. So this is the funding key. And the final is the channel master key, which is used to derive a set of keys, a set of base points for the Lightning channel. And we will derive a new channel master key per each newly created channel. And here, we include into derivation path, first of all, the Lightning version that we will be using. And by Lightning version, we mean that the existing Lightning network is a bolt, the one that is defined by bolt standards. We'll use 0 here, 0 hardened. And Bifrost, the future channels under Bifrost, will use 1 hardened derivation index. Then we will have a channel-specific index, and this channel-specific index will be 31 most significant bits of the remote node pub key hash. And the question here was how to make the channels differentiable from each other and at the same time recoverable, because if we will use just random information, we will not be able to find the keys after losing them. If we will use we can't use channel ID, the static channel ID, because it is generated after the funding transaction, and we need these keys already being derived to generate the funding transaction ID. So we can't use channel ID. The current version of LNP Node uses the temporary channel ID, which is created before the channel creation. But that has a drawback that temporary channel ID is not usually persisted as a part of the channel history, because you don't need it after the channel establishment. And it also creates problem with the recovery of the keys. So after certain thoughts, I decided that probably it would be the best way to use the remote peer public key hash it, and use some bits out of that public key, because you always persist with the channel the information with whom you had that channel. And you will use that information to recover the index for the key derivation used in the channel. And finally, there is the final index is basically the base point type you are using. I was showing all these keys in the key set that I used within the Lightning node. And basically the last index is the index of that key in the key set. So you see here that we have a channel specific index. So we are starting with the Lightning key. We are specifying that we operate on the mainnet. We specify that we operate, we derive a set of the keys for the channel. We specify the Lightning version, which is bold version, the channel specific index derived from the remote peer ID, and the final index defining the purpose of the base point that is being derived. So that's the proposal. And this proposal is on the GitHub. So I invite everybody, you have the link on the slides, this one. I invite everybody to come and comment and post your feedback there, because I think that this proposal may be useful outside of the LNP node for other nodes as well. So our funding transaction is still unconfirmed. That's pity. I have the last topic remaining for the call today. But anyway, probably we will have a question and answers. I will cover that last topic. We will have question and answers. And after that, we will check again how it works. I issued an improper comment to the console because I tried to connect the testnet, the test Lightning testnet instance. Anyway, so we can check the status of the channel a bit later. I'm just again saying that the channel actually has been created, and that there is a detailed information about the channel, and it's just that both nodes await the mining of that transaction. So if we will check again the Lightning clear list peers, we will see that the channel is awaiting lock-in. Okay, with the LNP node working with C Lightning, we still have several tasks that we would like to complete in order to get the full support of the modern Lightning network. And you can track these tasks in the GitHub. If you go to github.com lnp-bp LNP node, in the issues section, you will see that two tracking issues. The first tracking issues is basically the functionality of the bold specification. Sorry, not this one, this is the first one. Functionality from the bold specifications, as it is not just implemented in the LNP node, but tested against a C Lightning version 0.9, that it works correctly. So we are more than halfway on the implementation, and we're still working on the completion of the routing for HTLC payments, and we still need to work on the channel closing. So, but the most of the work is already done, and it was done during the December and part of November. So hopefully within the 1 month scope or less than that, we will have a Lightning network functionality completed, after which we will move to Bifrost part. Additionally to that part of the roadmap, we have a tracking issue that covers the core node functionality, aside from the Lightning specification, like persistence, configuration, history, and so on and so forth, relaunching, reestablishing. So these tick marks are also mostly done. We have several tasks to do. And we are really looking for a developer, a Rust developer with a good knowledge of Lightning, because first of all, to help finalizing LNP node and to transfer knowledge about LNP node to him. And after that, to have him as a full-time maintainer for the next years, from LNP-BP Standards Association, supporting and developing LNP Node on a permanent basis. So I will continue contributing to it, but I will work also on other protocols and aspects of RGB and so on, and we need somebody working full-time on LNP Node developing it further. Also, I would really encourage all interested to review and comment on LNP-BP 46 proposal, the one with the key derivation I described. It will be nice to get your feedback. And we are also looking for people who can maybe not work full-time on LNP Node as maintainers, but can contribute into finalizing the LNP Node. So with that, we good to go to the question and answers, and hopefully through that time we will have the node, the Bitcoin transaction mined such that we can check that C-Lightning have the channel and the active status.
Great. Actually, first question from me. Currently, LNP Node can establish the channels only with other LNP nodes or with LND or C-Lightning nodes also?
That's what I was demonstrating, is establishment of the channel with the C-Lightning node.
Exactly.
Okay.
Why cannot we establish the channels with LND nodes, for example?
With the LND node, we potentially can, I just haven't tested that. So I think that C-Lightning is just the most standard compliant node. And of course, we need to test with LND, but testing with the C-Lightning is sufficient, and it will indicate probably that we are already standard compliant. Maybe there could be some bugs with LND connectivity and so on, but they will be minor and not necessarily because that we are not standard compliant, but because maybe something there is not standard compliant. So this testing is needed, but basically as of today, I think the LNP node that we have is interoperable with existing Lightning nodes. That was the main point of the work that we were doing over the last months.
Great. There was another question that I got from one of the chats. Is LNP Node interoperable with Bolt 12? So reading through the Bolt 12 specification, it says that you can scan a QR code. Your wallet prompts you to pay it, just like Bolt 11 invoices today, through the QR code labeled one invoice. But it could also offer you to send you money, like for an ATM.
Well, there is no Bolt 12 finalized, so probably there is at least 3 proposals which I'm aware with the name Bolt 12, and one of them is offers, Lightning offers, so probably it's about them.
Yes, exactly. This is the one.
Offers here. It not necessarily will have the number 12, but no, it's not a standard yet, and LNP Node doesn't support it because it's a low priority. And why it's a low priority? Because we have our own invoicing standard that also covers RGB and on-chain. And basically, Bolt 12 doesn't help us a lot because it doesn't allow to support RGB assets. So we will use this universal invoice format, which we developed, and for both Bifrost, RGB, Lightning Network, and so on. That would be the format which we will support. And the design of this standard is mostly inspired by the work of Rusty Russell on the Bolt 12. It follows the same logic, but it has more expensive number of fields, and that is basically what LNP Node will support. So it will be Bolt 11 or Bolt 30. Of course, if somebody, or universal invoicing. Of course, if somebody will need the support for the Bolt 12, they are free to contribute, and that is not hard to implement. And the LNP Node will have Bolt 12. But I really recommend to do that after the finalization of the Bolt 12, when it will become an efficient standard.
Fair enough. Okay, those are 2 questions that I received from chats that I had. Any other questions, guys? Use the time to ask anything you want.
Hello?
Hello.
Yeah, sorry about earlier. This is Oflo. That was totally an accident. This is my first time using this platform. I do have a question, and it's about interoperability between
Mm-hmm.
Liquid and RGB.
Mm-hmm.
Yeah, is it interoperable?
No. Well, you mean RGB on chain? No, they're not interoperable. It's a different systems. Theoretically, you can add RGB. You can add support of the Liquid into RGB, such that RGB assets may be present in the Liquid network, but it will require certain work because the transaction structure of Liquid network is different from the Bitcoin one, and you have to do some deep changes into RGB. So that's not that hard, but again, there is little value of doing that because RGB basically allows much more complex smart contracts than Liquid, and it is more confidential than Liquid. So no need of you don't have a set information in the blockchain yet like you have in Liquid. Yes, it's blended information, but you have a scalability issues and many others. So basically, RGB may support Liquid, but it doesn't support it currently. Liquid, as for the question, will Liquid support RGB? We had a discussions with different blockstream guys that it could be a nice idea to have client-side validation, to have a Liquid version 2 made with a client-side validation and using RGB for that. But these are very preliminary. These were very preliminary discussions, so we are not there yet.
Thank you very much, and sorry about earlier.
No problem. Thank you.
The next question is from the chat. When will Bifrost be released?
Well, when we will finish the support of the interoperability with the Lightning Network, I just showed the roadmap for that, and after that, it will take several month or two to have the first test Bifrost version. So hopefully by the spring we will have Bifrost working at least at the same level as I am demonstrating the Lightning Network today. And that will allow us also to complete the RGB because they are really highly interconnected. What we can do while we are waiting for for this transaction to be mined is actually to establish the testnet channel, because it seemed that here we had quite slow fee and the fees on the mainnet had got risen through the last several hours. So I will quickly run and do the testnet channel as well, and up to the next call, hopefully that transaction will be mined and we will have two channels between the LNP node and C Lightning. So running the testnet, and I will get the test node running, LNP test node running here. So, so this is a testnet instance, and this is a command line tool. I will start with trying to check the amount of funds I have more funds on the testnet. Yes, there is a sufficient amount of funds. So I will open a channel for 80,000 Satoshis, test Satoshis, with the remote node. First, I will connect to it, of course. And then I will open the channel for 80,000 Satoshis. And what we have on this side. It hanged in. Accept channel is sent, but it haven't received our proposal for the channel creation. Why? I don't see any issues here. Accepted channel. Channel was already registered, so it remembers the last time we were creating the channel. So I need to wipe the database once again. It's a bit painful with the C Lightning because it doesn't allow having multiple channels with same peer. We'll go again to the SQLite testnet. I will wipe the data out. I will restart the testnet instance. And I will get back to the logging. Here, I'm doing all of that once again. Connecting and opening. And something goes wrong. As always. Why it's sticked in. Finding stage. Refund. Doesn't seem C Lightning doesn't send us a refunding transaction signature. Something wrong with that. Okay, so probably it's not. We already had spent too much time. We have a mainnet channel. The funding transaction published but not yet mined. We are looking for that transaction to be mined, but both nodes have the channel now, and they see the channel, and with the transaction getting mined, it will get operational. I stopped the mainnet LNP node to demonstrate the recovery of the channel. Even if it is not fully mined, we are able to recover the channel. We will see it here. I will change to the mainnet instance. We will see here that upon our disconnection, we see that the C Lightning lost the track of our node because I actually just killed it. And now I will try to reconnect and reestablish the channel. So I do bootstrap the LNP node once again. I giving it a command to connect to that remote node, C Lightning, and the C Lightning will instruct us to reestablish the channel, and that's what we will be doing. We will be restoring the channel state out of that command. So I think that is all for today call. We can have several questions if we are still have them, or otherwise we can wrap up and see after the new year having the channel transaction mined.
There is actually another question from the chat. I noticed you recommended BIP43 purpose keys. Will you also support BIP44 hardened keys?
Well, it's not about supporting BIP44. It's about that BIP43. If I'm not wrong, let me check that because it's really hard to get with these numbers. Bips. The BIP40.
43 and 44.
Yeah, BIP43. It says that we use the first component of the derivation path to denote a purpose. And we're using the first component of derivation path to denote the purpose that we generate a lightning key. So we are not supporting it, we are just following the BIP43 to with a specific index to have a lightning key out of which we derive the rest of the keys. The BIP44, it's completely different thing. It says about the multi-account hierarchy for deterministic wallets, and it says that for on-chain wallets, we can use these components after the purpose, like coin type, account, change, and address index. And it will not work for Lightning because it's not on-chain wallet. So the idea is that the Lightning application is very different. And while we're using the same style of BIP44, the change and address index, the last parts, for the funding wallet key here, we still basically use a different format. We have to use a different format for off-chain part of the channel key derivation and for the node key derivation. So we can't be compatible with Bolt with BIP44 in this regard there, because it is a different use case.
Okay, good. Any more questions, guys? Will there be a demo on the smart contract part of RGB anytime soon? If not, how far away are we?
Well, we have to finalize the Lightning part first, and we spent a separate developer call describing the roadmap for the RGB development. So we are on the Lightning part of that roadmap. So once we will finish the Lightning part, we will work on finishing RGB, and when it will be working, we will be doing a demo of it. I will not give any deadlines because it will be ready when it is ready.
So basically, I think you should, maybe if you're new to the dev calls or to what we're doing, we have a lot of interoperable stuff, interoperable nodes and protocols, but we work on them one by one, also because we don't have that many people in the team. So the LNP node is a part that would enable RGB over Lightning and RGB smart contracts over Lightning. So basically, it's not just a separate Lightning node that has no relation to RGB. Yes, it can be used just as a Lightning node, but it still would enable a lot of things that we have been preparing for RGB itself. So you probably need to also separate RGB, which can be used like as a second layer without Lightning, and as a third layer with the Lightning part. How big is the team? Well, it depends on what exactly you mean, because Maxim, probably you know this more than me. You live on GitHub. We have like around 40 probably contributors. Not some of them are active. Most of them probably not that much.
Well, yeah, there is no team per se. It's open source, free open source. Those people who come to GitHub, they can contribute. So there is no actual team. So I'm working for full time on this project for several years just because of my interest of it. And sometimes we get donations, and we had donations a year ago, and we got donations this autumn again. But the other time we are just doing that with our own funds. So this is a complete pure open source. No ICO was done, and there is no team, and it is just being developed as it is being developed. So that's why no deadlines, and we are moving forward as any open source project. So if somebody needs this to happen sooner, the only way you can do it is just to invest your funds into getting developers, more developers working on that, or to help develop it by yourself.
Yeah, so basically right now we're also looking for like proper Rust developers to join the team. So if you know someone that could, that are very good at Rust, or at least they're very ambitious and they have at least some experience in Rust, you can feel free to send them over to us. But overall, yes, if you want to speed up the process or expand the team, you basically just go to GitHub and search through the repositories. If you're the new guy, just pick up the good first issue tag on the task and deal with that. Probably that's the extent of it. Okay, so there's another question. That's not actually a question. Thank you so much for taking the time, visited the first time to get some insight. All the best for the holidays. Thank you.
Thank you very much. And
Happy
have
holidays.
great holidays.
Thank you. So if there are no questions, probably we should wrap this up for today. Happy holidays, everyone.
And see you in the new year. Thank you.
See you in the new year. Follow our repositories and happy 2022.
Yeah. Bye-bye.
Bye, guys.